Hi, I'm Gary Marcus. I'm a cognitive scientist. I also work on artificial intelligence. I built a machine learning company called Geometric Intelligence, which I sold to Uber last year. I also I have an op-ed in the New York Times about building a CERN for AI recently. And I'm a professor at NYU. The best thing that can make that happen is money. I mean, there's two things really. To really do it, to have something like CERN for AI, we need a lot of people collaborating, so we need people that are willing to put effort into building something that is not a commercial entity, that's not about making money, but is about changing the world. So I need help. And we also need some foundations, I think, to step up, and say, look, we're willing to be part of this, and we'll help you, get the governments involved and so forth. Doesn't have to only be academics. I do think there's a reason people get PhDs, and there's a kind of training that you get along the way. I don't think it's impossible for people without PhDs to contribute, but I think that having a proper understanding of the nuance involved in problems is important. And so, I would think most of the researchers involved would be, PhD trained researchers. Part of the point of a CERN for AI is that I think there needs to be coordinated action. So even academics, if you just have them all doing their own thing, it doesn't necessarily amount to anything. And so to the extent that you have software developers who don't have a PhD but are willing to participate in a larger enterprise and kind of help rather than necessarily each person having their own project, I think that can work. Oh, everybody's obsessed with deep learning right now, and I think deep learning is a really valuable tool, but it's just one tool in an armament that we need to do AI. So deep learning is very good for pattern perception, deciding is this a fork or a bottle or a cow, but it's not very good at understanding what a scene is about. If you saw a cow with a fork, you would think that's unusual, and you'd want to know why did the cow wind up with a fork. There's a sort of infinite range of unusual things you can see and immediately process. And deep learning can just label the objects without understanding what's going on. And then deep learning is not very good at language understanding. It can do translation, but it can't really answer questions. So we have systems like Siri and Google now that are still very limited. I have a 4.5-year-old, and he likes to kind of tease our Alexa system, finding all the ways of asking it to make the volume louder that it doesn't understand. Because we don't really have machines that understand language. Deep learning is a tool everybody's using, but it's not really getting the solution to that problem. I think what we need to do is to bring together two traditions. So the deep learning is part of a statistical tradition, and I think it's very important. There are lots of ways in which human understanding about the world includes keeping track of how often different things happen and so forth. But we also understand things causally. We represent language. There's a whole other side of AI that's not getting much attention right now. I would call it symbol manipulation or classical AI. And what I'm excited about is bringing these two traditions together. There's a kind of pendulum swing, and it's way over to the statistical learning side of things, and the other side's getting forgotten right now. We really need a synthesis of the two. We need to keep statistics, but we also need the abstract representational power of logic and computer programming to be part of this too. There's two issues. One is intelligence, and the other is power. You can look to my nation and see someone who's not super intelligent, but very powerful and then very dangerous. So I think a lot of times the arguments are cast around what happens when machines are super intelligent, but it's really more like what happens when machines drive all our cars. They don't have to be super intelligent, but they have to be hackable. That's when you get a problem. Super intelligence, I don't know if it'll ever happen per se. I don't think it'll be a single moment in time. Machines are already super intelligent when it comes to playing Go, and they're super not intelligent when it comes to playing one video game and then using that to help them play another video game. So there's a wide range of things that go into intelligence. Not a magical day when it happens, but the more autonomy we give machines, the more we have to be sure they can use it well. I thought it was so cool. I just got to meet the Afghanistan all-girls robotics team. I have a 3-year-old who's very into engineering. She's figured out what a screwdriver is, and when I was fixing one toy, she wanted to use it to fix another toy, to fix a chair actually. My daughter has a lot of engineering interest, and the world has not had enough female engineers, so I thought it was really cool. I got to meet the all-girls robotic team from Afghanistan. There's a tremendous amount of resources on the web now. If you want to learn about deep learning, they're wonderful tutorials. When I learned these things, there were a few books filled with equations, and if you weren't mathematically inclined, you couldn't even maybe get the gist. There are a lot of great demos out there now to learn techniques like deep learning. I think if you really want to be in the field of AI, you need some math chops. to do it well. But there's also lots of things nobody's paying attention to. Like reading some of the literature on AI in the 60s is actually pretty useful and something most people don't do. I find that uh, the kind of graduate students today have no historical perspective on the field. And I think there's a lot of room for people to say, well, why were they trying to solve these various problems in the 60s? And which of those have we solved now? And which are we still not really making progress on? And might be ready for a fresh approach.